Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Certificate Programs. Certificate in Information Technology, CIT. CIT-002 Introduction to Information Technology. Block-1 Elements of Information Technology. Unit-1 Attributes of Information Technology. 1.0 Introduction. Information technology, IT, and computers have enormous influence on all segments of our life. All our workplaces and the living surroundings are being mechanized or rather automated. The benefit of information technology is that it empowers people to do what they want to do, lets people to be creative, make people to be productive, and allow people to learn things which they didn't think they could learn before, and so in a sense it is all about potential. Technology, in all its forms, has had an impact on practically one and all. Information technology, with its complication and remarkable alteration, has debatably had the most philosophical force on community. Information is any type of pattern that influences the formation or transformation of other patterns. Information technology makes it practicable for all sorts of information to be stored, accessed and transmitted electronically, and with no orientation to customary print on paper media. In this unit, we will explore IT and its attributes. We start with the definitions of data, information, knowledge and wisdom. In the later sections, we will study types of information, quality of information, value of information, various forms of storing the information and effectiveness parameters of the information. 1.1 Objectives. After going through this unit, you should be able to define an attribute, define data, information, knowledge and wisdom, differentiate between data and information, differentiate between information and knowledge, describe the value of information, discuss the quality and significance of the information, and describe various ways to store the information. 1.2 Data, information, knowledge and wisdom. Data, a datum, a unit of data, derived from the Latin word is one or more symbols that are used to communicate something. They are raw facts that represent persons, places, things or events that have occurred or are about to obtain place. It is a symbol, sign or measure in a form which can be directly captured by a person or a machine. It is self-regulating, unrelated and limitless in number. It is raw, simply exists and has no significance beyond its existence. It can exist in any form, usable or not. Data represents a fact or statement of event without relation to other things. Example, it is raining. Information. Information is the interpretation of data. It is the data that has been processed, see figure 1.1, into an outward appearance that is having an important effect to the beneficiary, and is of authentic perceived value in the current or potential decision-making process. It is the data that has been processed in such a way that it can augment the knowledge of the person who uses it. The processing of the data and its appraisal, psychoanalysis and interpretation by users, alter it into constructive information. Look at the screen. Figure 1.1, Process of data conversion into information. Information embodies the understanding of a relationship of some sort, possibly cause and effect. Example, the temperature dropped 15 degrees and then it started raining. Knowledge. Knowledge consists of information that has been organized and processed to communicate understanding, experiences, accumulated learning and expertise as it applies to a contemporary problem or process. It is the appropriate collection of information, such that its intent is to be useful. Knowledge is a deterministic process. When someone memorizes information, then they have amassed knowledge. Knowledge represents a pattern that connects and generally provides a high level of predictability as to what is described or what will happen next. Example, if the humidity is very high and the temperature drops substantially, Atmosphere is often unlikely to be able to hold the moisture, so it rains. Wisdom. Wisdom is an extrapolative and non-deterministic, non-probabilistic process. It calls upon all the previous levels of consciousness, and specifically upon special types of human programming, moral, ethical codes etc. It beckons to give us understanding about which there has previously been no understanding, and in doing so, goes far beyond understanding itself. It is the essence of philosophical probing. Wisdom embodies more of an understanding of fundamental principles embodied within the knowledge that are essentially the basis for the knowledge being what it is. Wisdom is essentially systemic. Example, it rains because it rains. And this encompasses an understanding of all the interactions that happen between raining, evaporation, air currents, temperature gradients, changes and raining. Figure 1.2 shows the contemporary view of the data, information, knowledge and wisdom. Look at the screen. Figure 1.3 gives a clear view about the hierarchy from data to wisdom. Data is collection of isolated facts, information is data with outline, knowledge is applied and finely tuned information, and wisdom is at a standstill, more wide-ranging and significant. The terms data, information, knowledge, and wisdom can be presented in the form that suggests a scale depicted as shown below in the figure 1.4. 1.2.1 Data vs. Information. Data processing, DP, is any computer process that converts data into information or knowledge. The processing is usually assumed to be automated and running on a computer, as data is most useful when well presented and actually informative. Data processing systems are often referred to as information systems to emphasize their practicality. Nevertheless, both terms are roughly synonymous, performing similar conversions. Data processing systems typically manipulate raw data into information. And likewise, information systems typically take raw data as input to produce information as output. Figure 1.5 shows the conversion process of the data to information. Figure 1.5, conversion of data to information. Look at the screen. Let us study the differences between data and information from the table presented below. Table 1.1, distinction between data and information. Data and information. Data is raw. It simply exists and has no significance beyond its existence. Whereas information can be called as metadata, or data about data. The word data is derived from the Latin datum, literally a given or fact, which might take the form of a number, a statement, or a picture. Information, on the other hand, is facts or conclusions that have meaning within a context. Data is the raw material in the production of information. Information is the finished product, which is generated from data. The data is input to the process. To become information, data is manipulated through tabulation, addition, subtraction, division, or any other operation that leads to greater understanding of a situation. Data is just data which would not help in making decisions. Information is a collection of meaningful data which is useful in making decisions. Information is the input to decision making. 1.2.2 Information vs. Knowledge. Let us study the difference between the information and knowledge with respect to some of the important parameters. Table 1.2, distinction between information and knowledge. Look at the screen. Let us study the various types of information in the next section. 1.3 Types of information. Business organizations set up will have dissimilar levels. Each level has a dissimilar role to take part in. In order to be successful, each level has specific information requirements. The top management is involved in strategic activities, policy making, and goal surroundings. The central point management is mixed up in tactical activities, while the operating level is implicated in routine operations of the organization. The information requirements at unlike levels in the organization are dissimilar. The information can be considered as strategic, tactical and operational information based. on the receiver and user of the information. The details are as follows. Figure 1.6. Types of information. Look at the screen. Strategic information. The strategic information by and large relates to the top management functions in an organization. The strategic information deals with international and national subject, trends in the industry, investment patterns, government regulations and policies, competition strategies, technological trends etc. The strategic information prerequisite may be in-house as well as exterior in character. It is usually observed that strategic information from external sources plays more vital role than inner information. The temperament of strategic information is such that it adds on the long-term planning action. It includes future projections and forecasts etc. The strategic information may encompass essence that is not a direct result of conventional data processing activity using computers. The information about projected demand trends for a prearranged product based on population trends and estimates of purchasing power of the recognized buyer group of information about estimated cost of conservative fuels such as petroleum products and coal in the next 5 years are examples of typical strategic information that the top management employs. Tactical information. Tactical information usually relates to the middle management level in an organization. The tactical information takes in hand short-range planning action. The planning period addressed by tactical information is quantifiable in months and not years as in the case of strategic information mentioned above. Typical examples of tactical information are those of sales forecasts, cash flow projections, financial results, sales analysis, budgetary control and variance statements, capacity utilization plans, production plans etc. Some tactical information is acquired from external sources. For example, the information about product mix changes achieved by competition is tactical information collected from outer sources. In a usual environment, foremost segment of the tactical information is engendered internally inside the organization. Tactical information is characteristically produced through data processing activity. Operational information. The operational information, as the name recommends, deals with particular operations within an organization. The operational information is often produced as a result of data processing. Movement. Exact users, often limited in numbers, are users of the operational information. The operational information is more precise than other types of information. Some of the additional widespread examples of operational information are day-by-day attendance report, pending purchase order statement, item-wise stocks held, work in progress, shift reports etc. This operational information is used as a data for further processing to get hold of tactical information. Typically, the information systems produce dissimilar types of information that meet the organization's information requirements. Information systems are designed to be flexible enough to meet the changes in information needs by types and contents. 1.4 Sources of information. Information is obtained from different sources in an organization. The sources of information can be classified by their nature into internal and external. External. The external information sources are characteristically related to the surroundings in which the organizations function. In real-life situations, the external sources of information comprise of government, trade organizations, published information, newspapers, news agencies, banks and financial institutes, customers and suppliers etc. Specific external information sources include market, research and marketing intelligence agencies. Internal. The internal sources of information consist of the functional or departmental data processing activities. These activities fabricate information which is used at operational, tactical as well as strategic levels within the organization. The quantity and degree of processing required to engender the desired quality and quantity of information varies according to the information requirement. 1.5 Quality of information. Quality of information is tremendously noteworthy in an organization. Information is used for planning and control functions. Information is a fundamental input for decision-making activities. If the information used is not of the right quality, it is bound to unfavorably affect the actions based on such information. In a typical environment, with numerous types of information and with large information volume, it becomes moreover non-specific to characterize the term quality of information. The guiding attitude used in this case is the definition of the term quality. If quality is defined as conformance to the requirements, it becomes trouble-free to stick to this definition in an organization. Information is used in a diversity of applications. It is used for planning, controlling, motivating, staffing, coordinating, decision-making etc. Each of these activities has a confident set of requirements about the information. If the information produced meets these requirements, the information can be considered as quality information. 1.6 Value of information. Information extends the concept of data in a broader context. Information plays a very significant role in organizations. Smooth flow and proper utilization of information is important for the very continuation of the organization. Information is a key input in decision-making action. If erroneous or imperfect information is used as the basis for decision-making, the resultant decision itself will be distrustful. Information is pertinent and useful knowledge produced as output of processing action. Information is used to present increased understanding or for decision-making, or to accomplish explicit objectives. Information by itself does not have a value characteristic. The value is gained through suitable application of the information in explicit activities. Theoretically, value of information is measured to be the value of the change in decision behavior resulting due to information less the cost of obtaining the information. The mathematical model of computing the value of information in decision making takes into consideration the payoff matrix and computation of the value of information. By assigning the values of change in the decision behavior and the cost of obtaining the information, the computation of values of information has to take into account the degree of certainty and extent of risk and optimal solution. Figure 1.7, Mathematical Model for Computation of Value of Information Source, AMRA Research. Look at the screen. When innovative information results in a dissimilar decision, value of such information is obtained by subtracting the value of previous decision from the new decision. If the new information does not affect in a new decision, the value of information is considered to be nil. The value of perfect information is calculated by finding out the difference between the optimal policy with and without perfect information. In addition to decision making, information plays a significant role in activities such as planning, control, coordination, motivation etc. The value of information in such application areas may not automatically be quantified. The value of information in planning is manifested through the degree of correctness in forecasting the future events, realistic estimations, success probability etc. In the context of control activities, the manifestation is in terms of response time for feedback control loop completion, accuracy of measurement etc. 1.7 Storage of information. Data storage is the holding of data in an electromagnetic form for access by a computer processor. There are two main kinds of storage. Primary storage is data that is held in random access memory, RAM, and other memory devices that are built into computers. Secondary storage is data that is stored on external storage devices such as hard disks, tapes, CDs. The Table 1.3 summarizes the main methods of data storage. Table 1.3 Way of storing information in a distinguished device. Method and explanation. Hard disks, often called a disk drive, hard drive or hard disk drive, this method of data storage stores and provides relatively quick access to large amounts of data. The information is stored on electromagnetically charged surfaces called platters. Floppy disks. A floppy disk is a type of magnetic disk memory which consists of a flexible disk with a magnetic coating. Almost all floppy disks for personal computers now have a capacity of 1.44 megabytes. Floppy disks are readily portable and are very popular for transferring software from one PC to another. They are, however, very slow compared to hard disks and lack storage capacity. Increasingly, therefore, computer manufacturers are not including floppy disk drives in the products as a built-in storage option. Tape storage. Tape is used as an external storage medium. It consists of a loop of flexible celluloid-like material that can store data in the form of electromagnetic charges. A tape drive is the device that positions, writes from, and reads to the tape. A tape cartridge is a protectively encased tape that is portable. Optical discs. An optical disc is a storage medium that can be written to and read using a low-powered laser beam. A laser reads these dots, and the data is converted to an electrical signal, finally converted into the original data. CDR, compact disc recordable, CDR, discs have become a universal data storage medium worldwide. CDRs are becoming increasingly popular for music recording and for file storage or transfer between personal computers. CDR discs are write-once media. This means that once used they cannot be erased or re-recorded upon. CDR discs can be played back in any audio CD player or CD-ROM drive, as well as many DVD players and drives. CDRW, compact disc rewritable, CDRW, discs are rewritable and can be erased and re-recorded upon over and over again. CDRW discs can only be used on CD players, CD-ROM drives, and DVD players and drives that are CDRW playback compatible. DVD, a DVD, digital versatile disc or digital video disc, is a high-density optical disc with large capacity for storage of data, pictures, and sound. The capacity is 4.7 gigabytes for single-sided, single-layer DVD disc, which is approximately 7 times larger than that of a compact disc. 1.8 Information effectiveness parameters. Information can be identified by effective parameters. The degree of significance for each of these parameters would differ depending on organizational and environmental factors. The information parameters are as follows. Exactness. The information make available for managers to make decision must be adequately exact. Nobody expects total accuracy at any cost. Rising of correctness level at times amplify the cost significantly. Suitable height of accurateness is matter of judgment in a given state of affairs. Timing. The information must be communed to the actual user of the information at appropriate time. Even imperative information, if made accessible late, becomes outmoded. Contents. The contents of information must be proper to congregate the user. Necessities. Unnecessary information must be eradicated so to avoid information overload, leading to misunderstanding. The contents of the information idyllically should be administered by the user of information, relatively than by producer of information. Should be complete and accurate in nature. Appreciative. The information which is endowed with should be effortlessly unstated by the genuine users. The information in cryptic form using complex codes, though exact, may not be comprehensible to the end user. The straightforwardness of understanding is vital for effectual usage of information. 1.8 Information effectiveness parameters. Information can be identified by effective parameters. The degree of significance for each of these parameters would differ depending on organizational and environmental factors. The information parameters are as follows. Exactness. The information make available for managers to make decision must be adequately exact. Nobody expects total accuracy at any cost. Rising of Correctness level at times amplify the cost significantly. Suitable height of. Accurateness is matter of judgment in a given state of affairs. Timing. The information must be communed to the actual user of the information at appropriate time. Even imperative information if made accessible. Late becomes outmoded. Contents. The contents of information must be proper to congregate the user. Necessities. Unnecessary information must be eradicated so to avoid information overload, leading to misunderstanding. The contents of the information idyllically should be administered by the user of information, relatively than by producer of information. Should be complete and accurate in nature. Appreciative. The information which is endowed with should be effortlessly unstated by the genuine users. The information in cryptic form using complex codes, though exact, may not be comprehensible to the end user. The straightforwardness of understanding is vital for effectual usage of information. Cost-effective, balance the cost-benefit. Let us go through the various types of information systems in the next section. 1.9 Types of information systems. For most businesses, there are a variety of requirements for information. Senior managers need information to help with their business planning. Middle management needs more detailed information to help them monitor and control business activities. Employees with operational roles need information to help them carry out their duties. As a result, businesses tend to have several information systems operating at the same time. This revision note highlights the main categories of information system and provides some examples to help you distinguish between them. Below given Table 1.4 summarizes various types of information systems and their purpose. Table 1.4 Various types of information systems. Information system and description. Executive support systems. An executive support system, S, is designed to help senior management make strategic decisions. It gathers analyses and summarizes the key internal and external information used in the business. A good way to think about an S is to imagine the senior management team in an aircraft cockpit with the instrument panel showing them the status of all the key business activities. S typically involves lots of data analysis and modeling tools such as what-if analysis to help strategic decision making. Management information systems. A management information system, MIS, is mainly concerned with internal sources of information. MIS usually take data from the transaction processing systems, see below, and summarize it into a series of management reports. MIS reports tend to be used by middle management and operational supervisors. Decision support systems, DSS, are specifically designed to help management make decisions in situations where there is uncertainty about the possible outcomes of those decisions. DSS comprise tools and techniques to help gather relevant information and analyze the options and alternatives. DSS often involves use of complex spreadsheet and databases to create what-if models. Knowledge management systems, KMS, exist to help businesses create and share information. These are typically used in a business where employees create new knowledge and expertise which can then be shared by other people in the organization to create further commercial opportunities. Good examples include firms of lawyers, accountants and management consultants. KMS are built around systems which allow efficient categorization and distribution of knowledge. For example, the knowledge itself might be contained in word processing documents, spreadsheets, PowerPoint presentations, internet pages or whatever. To share the knowledge, a KMS would use group collaboration systems such as an intranet. Transaction processing systems, as the name implies, transaction processing systems, TPS, are designed to process routine transactions efficiently and accurately. A business will have several, sometimes many, TPS, for example, billing systems to send invoices to customers, systems to calculate the weekly and monthly payroll and tax payments, Production and purchasing systems to calculate raw material requirements. Stock control systems to process all movements into, within and out of the business. Office automation systems. Office automation systems are systems that try to improve the productivity of employees who need to process data and information. Perhaps the best example is the wide range of software systems that exist to improve the productivity of employees working in an office. E.g., Microsoft Office XP, or systems that allow employees to work from home or whilst on the move. 1.10 Summary. Computers are often called data processing machines or information processing machines. People understand and accept the fact that computers are machines designed for the input, storage, processing, and output of data and information. Information technology and business are becoming inextricably interwoven. I don't think anybody can talk meaningfully about one without the talking about the other. Bill Gates. According to Russell Ackoff, a systems theorist and professor of organizational change, the content of the human mind can be classified into 5 categories. Data, symbols, information, data that are processed to be useful, provides answers to who, what, where, and when questions. Knowledge, application of data and information, answers how questions. Understanding, appreciation of why. Wisdom, evaluated understanding. Thus, IT is an enabler to enormous advances in human work in every field, which is essential to stay alive in the competitive world. Basically, the use of IT at workplace and personal life direct us and rather facilitate how to study information technology. In this unit, we have studied about the data, information, knowledge and wisdom. We have seen the differences between them. In the later sections we have studied the types of information, quality of information, value of information, various forms of storing information, effectiveness parameters and types of information systems. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.